Recovery of my presentation is recovery of nickel and cobalt from low-grade nickel laterite ore of Sukinda, Odisha, India, using microorganisms. I am Professor Lala Behari Sukla. I am Director of Biofuel Bioprocessing Research Center, Siksha O Anusandhan University. I am working on this. It's not coming. My presentation outline is introduction, microbes involved in nickel and cobalt recovery, bioleaching of lateritic nickel ore using heterotropic microorganisms, then recovery of nickel and cobalt from thermally pre-treated lateritic ore by consortia, mesophilic, acidophilic bacteria, nickel recovery from lateritic ore by microbial reduction using acid thiobacillus peroxidant, application of direct iron reducing bacteria or enhancement in recovery of nickel and cobalt from low-grade lateritic nickel ore, development of a microbial process for recovery of nickel and cobalt from chromite overburden. Not coming. The biomineral processing is suitable for different resources like low-grade ore, complex and refractory ores, and industrial waste, where conventional technique fails. Advantage is naturally occurring microorganism, avoid toxic emission, eco-friendly, simple in operation and maintenance, low capital cost, suitable for small-scale plant. To preliminary types of nickel ore deposits, you will find lateritic ore, oxidic ores, and nickel sulfide ore. Lateritic oxide ores are predominantly low-grade nickel ore found worldwide, 80% of world deposits. And this is I'm showing the mine site, the lateritic chromite overburden. And this is about 67 million tons. In addition, 140 million tons of accumulated over the years. Nickel occurs in adverse state. The elemental analysis is given here. Nickel around 0.78%, cobalt 0.03%, iron 45 to 50% around, manganese 0.61, chromium 2.62, around 2.6%. Nickel occurs in observed state with iron, goethite that is. Hello. These are the conventional methods of nickel extraction. We drying, calcination, and then smelting, refining. We get smelting, ferronickel matte. We get. Then lateritic ore also by Caron process, drying, calcination, reduction, ammonia leaching, purification, recovery. We get nickel and cobalt. Lateritic with high pressure leaching, CCD and neutralization, precipitation, purification. We get nickel and cobalt. I am going to suggest this process: lateritic nickel ore, isolation and growth of efficient microorganism, bioleaching of ore, then purification and recovery, we get nickel and cobalt. The application of micro for mineral processing has been extensively studied for recovery of copper, gold, and cobalt, and uranium. The microorganisms which play a vital role in bioprocessing of minerals are broadly classified autotrophic and heterotropic according to their nutritional behavior. Chemolithotropic group of microorganisms has been widely applied for processing of sulfidic ores. The reduced iron and sulfur compound present in the sulfide ores can support the nutritional requirement. The majority of the chemolithotropic microbes reported for mineral processing belong to acid thiobacillus peroxidant, leptospirillum, sulfobacillus, etc. The use of chemolithotropic microorganism processing laterite ore has been discouraged, and heterotropic organisms belonging to different strains, fungi, bacteria are also most widely used microorganisms in bioprocessing of laterite ore. Fungal strains, Aspergillosis, Penicillium, and bacterial strains of Bacillus also have been widely studied microbial strain for recovery of metal values. These microbes synthesize organic acid, oxalic, citric, oxalic, gluconic, etc. as metabolic byproduct during the cellular metabolism, and these metal chelating properties and the acidity generated in the organic metabolics is responsible for solubilization of metals from lateritic ore. Then we did some work on biological using heterotropic microorganisms. We have used thiobacillus peroxidans, biocirculans, bacillus circulan, bacillus licheniformis, and A. niger. These are some of the recoveries. We got A. niger, maximum 92% recovery, whereas bacillus circulan we got 85%, thiobacillus got 6%. The mechanism, the acidity generated by the cellular metabolites of our fungi is involved in breakdown of the metal oxygen compound, lateritic minerals, and the proton ion of organic acids and first attack the oxygen atom in the metal oxide compound laterite. The following equations are representing generalized reaction during the acid hydrolysis of mineral during fungus mediated bioprocessing. These are the quantity of nickel leaching in flash and bacillus circulan, bacillus licheniformis, and A. niger. So these are range of 45 to 85, 12 to 35, 2 to 92. Exposure has the maximum effect 92% in 22 days. Oxalic acid is the prominent metabolite secreted by several fungi under specific conditions which act as a metal chelating agent. Aspirin is the best option for microbial production of oxalic acid during fungal leaching. Metabolic pathway of oxalate biosynthesis N-izer involves one of the prominent cytoplasmic enzymes, oxaloacetate, acetyl hydrolase, which catalyze the breakdown of oxaloacetate metabolic intermediate to oxalate and acetate. A study with the oxalic acid with production of N-izer in response to manganese supplement and its growth media, which in turn improves the metal recovery and nickel recovery. The maximum nickel recovery was achieved 38% pre-treated chromite overburden. Chromite overburden is lateritic nickel ore only. Is just above the chromite mine. There are about 3 to 4 meter height. This overburden is available, which contains nickel. The manganese culture media where 24% nickel and or the presence of surfactant also we have tried that like polyoxyethyl in mono-laterite we have used for bioleaching purpose also. The recovery of nickel and cobalt was thermally pretreated later by consortia of mesophilic acidophilic. We found that method on because goethite is present, nickel is present in the goethite structure. So we have to, unless we break that structure, nickel will not come out from the this goethite matrix. So we have thermally we have heated the material at 400, 600, and 800, and we have used mesophilic thiobacillus peroxidans consortium consisting of predominantly acid thiobacillus peroxidans strain are used for bioleaching. Nickel recovery from thermally activated sample 300, 400, and 600, 800 was 21.03, 41.33, 59.18, 29.03 decimal. The cobalt recovery with same conditions we could find 22%, 45%, 65%, and the only maximum is at 600 degree we could get maximum nickel and maximum cobalt. Maximum recovery of nickel and cobalt observed retreated sample at 600 at 10% pole density, 59.18%, and 65.09% cobalt respectively. Optimum condition is pH 1.5, temperature 30 degrees, second rate is 150 rpm, incubation period is around 10 days. The roasting of the ore about 400 degree and above has been reported to convert goethite to hematite. Nickel may become exposed in microporous and cracking developed in the particles. Drawback this lies in the thermal treatment is its effective terms of energy consumption and may not be employed in a large-scale operation. These are some of the nickel and cobalt recoveries we have done at different conditions. This is 300, this is 400 degrees centigrade, this is at 600, this is 800 degrees. The work focuses on the efficient utilization of laterite chromite overburden for extraction of nickel from anoxic reductive microbial process of acid thiobacillus peroxidant. We have used elemental sulfur in this experiment, and we could improve the nickel extraction. And this was done at 3-liter bioreactor maintaining anoxic conditions. The results showed that 41% nickel extraction was achieved in anoxic condition 18 days from chromite overburden containing 1% nickel. Acid thiobacillus will reduce the ferric iron goethite phase of the chromite overburden under conditions present in presence of sulfur. Sulfur was oxidized to hydrogen sulfate, subsequently converted to sulfuric acid. Sulfuric was responsible for dissolution of nickel and iron from chromite overburden. This study reports higher amount of nickel recovery from chromite overburden. This can be explained by the following equation as reported by this: sulfur plus ferric ion becomes sulfuric acid and ferrous 7 and hydrogen ion. Then we direct DIRB we have ability to utilize ferric ion as a terminal electron acceptor during bioreduction of laterite ore. In this process, direct iron reducing bacteria consortium reduces the goethite phase in hematite phase to hematite and magnetite with exposure of nickel oxide. Subsequent leaching of DIRB pretreated with ore by sulfuric acid resulted in enhanced nickel and cobalt recovery. These are some how we have treated. One aspect we can treat by thermally also convert goethite to hematite, and by using also direct iron reducing bacteria also you can convert the goethite to hematite, and acid leaching, and we get nickel extraction using these processes. These results are shown here. We have a flow sheet was developed for the recovery of nickel and cobalt from chromite overburden to a bioreduction acid leaching. We have patented it, and we have developed this name as BRL, a biohydrometric route to recover nickel and cobalt. And then we have developed a microbial process for recovery of nickel and cobalt from lateritic nickel ore Sukinda. To develop the process of biology column heap for extraction of nickel and 1 ton to 10 ton scale, and recovery of metals from leach liquor by precipitation, solvent extraction, membrane technology, and electrowinning process. Sample we have received 5 types of chromite overburden sample from Sukinda in Odisha, India. Formally activated the ore. Then scale of work, sec plus fast we tested the material using sec plus gram scale. Then we have scaled up to 1 ton and 10 ton scale. We have used acid thiobacillus peroxidant are autotrophic organism, so extra carbon source is not required. They are acidophilic and 1.5 to 2.5 pH, therefore no cross contamination happens. The organisms were adapted to nickel concentration ranging from 0.25 to 1 gram per liter. Attachment, there are interfacial phenomena which attachment occurs caused by leaching attachment. AFM studies also clearly shows various bacterial configurations such as bacteria engagement matrix, which may be EPS secreted by the bacteria during biofilm formation. These are the AFM studies we have done. Acid thiobacillus peroxidant, a large area of scan of the film. These are also AFM images of acid thiobacillus peroxidant bacterial colony, images of the single colony. This is single colony, this is rod shaped. So these are the condition adaptation to overburden, activated carbon, Wall density 2 to 20%, temperature 30 to 35, speed RPM is 150 RPM, pH 1.5 to 2, duration 0 to 30 days, and bacteria concentration biomass is 10 to 8 cells per ml, and media we use lower ferrous sulfate 9K media plus. This is 1 ton scale. This is bacteria generation tank we have here. We have a leaching tank. The leach liquor is collected here. I am collecting the leach liquor for analysis. These are some of the pH, how pH was maintained here around 1.5 to 1.6 or something. The bacteria concentration was varying 10 to the power 5 cells per ml. Nickel recovery was given around 45%. Cobalt also around 45 to 60%. These are 10-ton scale by heap leaching plant. These are the heap we have produced, 10-ton material, pre-treated material, and these are leach liquor prepared. We have a tank, and we have circulated the tank to the top of the material, and it slowly percolates and comes, and is being it will come back to this same tank, and wherefrom we can take the solution for nickel extraction. This is continuously recirculated to get a desired nickel concentration, so that it can go for solvent extraction and electrowinning purpose. So these are some of the bacteria concentration during 10-ton scale. This is metal extraction, nickel extraction, and cobalt extraction. This typical sample analysis leach liquor, we got about nickel 0.64 gram per liter, cobalt 0.03, iron 2.5. After the solvent extraction, removing the nickel, we circulate the same solution for leaching purpose. This is the separation of metal leach liquor using solvent extraction. We have used leak 64N, and this is the composition of laterite or leach liquor. Iron 3.719, manganese, nickel, cobalt, pH is 1.27. We did the electrowinning also. We got the nickel cathode. This is the purity of about 99.9975% pure nickel we could produce. It observed that microorganisms are more susceptible to leach nickel from the thermally activated overburden. Nickel resistant strain acid thiocellulose peroxide was developed by adopting to nickel to different concentration of nickel ranging from 1 to 1.5 liter. Extraction of nickel and cobalt in SEC class, we could find 66.94% nickel, cobalt around 72.7%. Nickel cobalt recovery 1 kg scale were 60 to 65 and 65% after a period of 60 days. In case of leaching 1 ton scale column leaching, the percentage of nickel and cobalt recovery 35 and 40% in 9 months. The percentage of nickel and cobalt recovery 25 to 31% 9 months in 10 ton scale. For nickel and cobalt, the impurities like iron and chromium, aluminum and chromium were precipitated using calcium carbonate at pH 4.4, and high pure nickel was deposited from the pregnant electrolyte using synthetic spent electrolyte and actual biological liquor. Current efficiency during electrowinning 55% and energy consumption was 5 kilowatt hour per kg. Process modeling and simulation help in obtaining the optimal condition which system can be operated to get a maximum benefit. In the present study, empirical models were developed to optimize the process parameter or maximize the bacterial leaching of nickel and cobalt. Nickel reduction from lateritic overthrow microbe mineral is easier due to the production of organic acid and chelating compound by the microbial Nickel cobalt recovery process by using direct iron reducing bacteria and chemotherapy bacteria can provide develop commercial approach towards low-grade ores extraction of nickel and cobalt. Heterotropic microbial strains used in mineral processing shows high metal quality metal recovery. Over a period of time, practicing these methods tremendously increased due to its cost effectiveness and environmental safety perspective. Thank you.